Hello everyone, I'm explaining question number 4 of your specimen paper. Okay, this is an APGP question that's not really easy to handle. It's a typical bouncing ball question which you actually have in your lecture notes. So this story is that a student drops a ball from a height of 160, and then after every bounce, okay, it reaches 7/8 of the original height. Okay, so the first part of the question asks for the total distance that the ball has traveled after it reaches, when it reaches the highest point after the third bounce. So to handle this question very effectively, what is very important is that you set up a table together with a drawing to actually explain to you what is actually happening. Okay, and for your table, it is very critical that you label your header very clearly. So the distance that you want to start calculating is taking reference from the top. Okay, and then you want to follow the instruction of the question. The question asks for the total distance after the third bounce. So I find the total distance from the top traveled by the ball after every bounce. Okay, so what happens is that after the first bounce, what is the distance traveled by the ball? After one bounce. So what happens is that the ball drops from the height, it comes down. After one bounce, it goes up again, and then it comes down. Okay, so when it comes down, this is the total distance it traveled just before it hit the floor for the second time. So the distance traveled will be 160 for the initial drop. Then it bounces and reaches 7/8 of the height of 160. So that's what's happening. But why do I times 2? Because it goes up and it comes down. So there's a double distance. Okay, it travels up and comes down. So this whole section, this whole thing in yellow here, actually is the total distance traveled by the ball after the first bounce. So what is the distance traveled by the ball after the second bounce? Is that after it bounced the first time, it goes up again and then it comes down. So I need to add on this blue segment. So this blue segment comes from 7/8 square multiplied by 160. So why do I need times 2 again? Because there is an upward and downward motion. Then on the third bounce, what happens? This time around, the question is only interested in the distance that it reaches when it reaches the highest point after the third bounce. So after the third bounce, there is only this upward motion, so which is 7/8 cube of 160. And this time around, I don't need to times 2 because I'm only interested in the upward motion. So this is the total distance traveled by the ball after the third bounce. I sum up everything, I get 792.1875. Okay, so moving on to the second part, I need to find when does the ball actually stop bouncing. So the criteria here is that the ball is considered to have stopped bouncing. Okay, the ball is considered to have stopped bouncing when it reaches a height of less than 0.01. Okay, so how do I actually pinpoint when does the ball stop bouncing? So I need to go back to the question again. Okay, initial first part. What is the height reached by the ball after the first bounce? So this is the height reached by the ball after the first bounce. What is the height reached by the ball after the second bounce? This is the highest that it can go after the second bounce. What is the highest it can go after the third bounce? This is what's happening. So if you actually realize there's actually a pattern. 2 accompanied with 2. 3 accompanied with 3. So what is the height reached by the ball after the nth bounce? Will be 7/8 to the power of n multiplied by 160. So I need to equate this to be less than 0.01. So I actually create an inequality here for me to solve for n. So when you're solving this, just be a little bit careful. When you take ln on both sides, you're dividing by a negative number, your inequality sign changes. So the ball has made 73 bounces that is considered to have stopped bouncing. So that's only the first part. The second part of the question asks you to tell or find the total distance traveled by the ball in these 73 bounces. So how do I go about that? Okay, you need to rely on the table that you have actually generated previously. Okay, so let's go back again. This one, Okay, it's the total distance traveled by the ball after one bounce. This is the total distance traveled by the ball after two bounce. This is the total distance traveled by the ball after the third bounce. But be careful, this one we stop counting, okay, because the question say I stop counting when it reaches the highest point. So actually, I need to times 2, right? Okay, so if I were to follow the same pattern, what is the total distance traveled by the ball in 73 bounces? So let's try and generate again. Okay, so after one bounce, what's the distance traveled by the ball? It is this, if you take reference from your original part. Okay, why 2 times? Because there's upward down motion. And what's the total distance traveled by the ball in the second part? Or after the second bounce, it is the same. We add on the blue segment and multiply by 2. And what's the total distance traveled by the ball on the third bounce? This time round is 7 over 8 cubed, 160 times 120. So we're going to add on and on and on until the 72nd and 73rd. So you follow the pattern and generate accordingly. Okay, so after you generate this whole entire sum down here, you spot for pattern. So 160 stays as it is. I am going to factor out 7 over 8 of 160 times 2, which is 320 multiplied by 7 over 8. And this is what we have in the big bracket. In this big bracket, we actually see a GP. Okay, the GP, the first term is 1. The common ratio is 7 over 8. How many terms are there altogether? There are actually 73 terms. And I actually activate sum of GP. Okay, I actually activate sum of GP. This whole thing here, okay, activating sum of GP, I will see this. Work out the calculation via calculator and you get a total distance of 2,400.